well, we will go ahead and get started. I'm Liz Hoy. I'm in the Carbon Cycle and Ecosystems office at NASA Goddard, and I help to run these ABoVE Science Cloud webinars, which are an opportunity for people using the ABoVE Science Cloud to hear about other people who are using the cloud, to ask questions, and work through any issues that you might be having. We try to have a guest speaker each time, and then just have a time for Q&A at the end. So today we have Dr.Stofferahn, who was a former postdoc of Josh Fisher's on their model integration project. And now, Eric, you work for, where are you working now?
It's a place called Conservation Science Partners. We do basically an analysis in service of like wildlife and landscape conservation.
But he's still working with Josh Fisher to finish up this model integration project, and so that's where we've asked him to come and talk. He's used the ABoVE Science Cloud pretty heavily, and he's got some data sets stored on the Science Cloud, so he's going to give us a talk about the work that he's been doing on the Science Cloud, and then we'll have a chance for questions at the end. You can chat them in the chat box as we go along too. We'll monitor that, and we can ask Eric, and then we'll just kind of have a time for system updates at the very end. So go ahead, Eric. Thank you for joining us today.
Cool. Thanks for having me. So I just wanted to give a brief background about what the actual ABoVE benchmarking system is, and then I'll get a little bit into how it's implemented on the Science Cloud. So our motivation for building this in the first place is we wanted to see how well models performed when they're trying to look at various indicators that have been identified as key indicators for the Arctic boreal region. So we've identified kind of 5 overarching indicators: carbon, disturbance, ecosystem or flora, fauna, hydrology, and permafrost. And each of those areas has variables within it that are output by the model, and also variables that we observe as part of the ABoVE campaign or as part of in situ or remotely sensed observations that are still within the ABoVE domain, but not a part of the ABoVE campaign. So what we'd like to do is evaluate these models against data sets that currently exist, both within ABoVE and outside of ABoVE. So we took as our starting point ILAM, which is the International Land Model Benchmarking System. And that's a good start. It provides a framework for scoring and being able to evaluate your model. What we wanted to do is build something that was uniquely for the ABoVE campaign and the ABoVE domain in particular. So if you can see on the lower right is the kind of 2 polygons that make up the ABoVE domain, and that's something that's been developed, the ABoVE projection, which I think is Canada Albers equal area, and the grid that goes on top of that, sorry I don't have a picture of that, is something that was developed, I think, by Tatiana and Mark and you, Liz, if I'm not mistaken.
Yep, that's right. Yep, you got it.
Sorry, go ahead.
No, you're right. That's right.
Okay, cool.
You can actually, the grid is downloadable on the Oak Ridge National Labs DAC, the ORLNL DAC. It's there, so if anybody ever wants that grid and projection, you can find it there.
Cool. Yeah, and I've, as you'll see, I've used that heavily in this process. So we've our 2 parts of kind of separating it from ILAM was, one, we're only going to be making these comparisons over the ABoVE domain, which really does reduce the kind of data store of data sets that we have to use because it's much smaller in spatial extent. But we also wanted to concentrate on variables that are pertinent for above. Just kind of as an overview of that, just one component, that carbon component of the above benchmarking system. So we've got a list of variables there on the left, and I should mention at this point that this is a very fluid list. If you see something on there that doesn't belong, let me know, and I can dump it. If you see something that's missing on there, let me know, and I can add it. As of this point, I'm basically the sole person responsible for adding. I don't think I've technically removed any data sets yet, but I'm the one responsible for adding data sets. So let me know. I know some of you already have. You know, just to get an idea of certain variables like, let's go with NEE, Net Ecosystem Exchange. What I'd like to have on there, and I do have on there for some of these variables. I haven't implemented all the ones I want to implement yet either. But so something specifically like there was a product that Roisin Comain put out that was based on carb measurements over Alaska that I found was a very nice NEE data set. And so what we can do is take that data set, house it on the Above Science Cloud, and then we can use that to test the models, essentially. So, and this is a little hard to see, apologies for that, but there's kind of a cyclical process here. So what happens is you, I know it says user uploads model here, but at the moment, all of that is filtered through me again, unless of course you do have, I guess most of you guys have access to the cloud, which is good. So you can actually drop a model result into the appropriate folder, and it will, the system, I've got a cron job that actively looks to see if there's something new in there, and if there is, it'll run the system. But for somebody who doesn't have access, who wants to, they would have to send it through me so I could upload it. So I don't know if you can see my cursor at all, but the user.
So if you want to share your cursor, I think up at the top you see there's an option for draw, and then there's an arrow, and then it says stop sharing. So yeah, I think now we should be able to see your cursor. Let's see.
Can I drag this?
Now
Yeah.
yep.
What? Okay. Cool. So, so the next step is, yeah, the benchmarking system firing up, calculates the scores, makes graphics, builds a web page. Another kind of addendum there that the web page building right now is kind of in a state of flux. We're sort of transitioning from one style to another style, and so I'm probably going to have to do additional work to make that something that's usable and presentable. But you can still get the scores. And then the person who submitted the model could view the results on that web page. Again, at the moment, that's basically generating something that's, so a web page that could, in theory, be hosted on the cloud itself, although that would then only be viewable to people who have access to the cloud and who log in with some kind of X server or something like that, so they could actually view it. But nevertheless, hopefully that we can get that up and running at some point, or we'll find another way to kind of host the web page somewhere. And then, so essentially this is sort of designed for model developers in particular. So you've got a certain version of your model, you spit out results, you run it through the system and you get your score, and you're like, okay, it didn't do so great in some of the carbon variables. Maybe we should make some adjustments there. You make your adjustment, you upgrade to version 1.1 or whatever, and then you run it through again. It doesn't take terribly long to actually run through the system. So in theory, as soon as you've got a new version, you could push up the results, get your new scores, and then kind of go through that iterative process to improve your model. So I just kind of wanted to outline the basic steps of what the code does. And hopefully if I can do a screen share, maybe we can see what this kind of looks like in code itself, if anyone's interested in that. Otherwise I'll skip it. But the basic idea is to load the kind of structure of the scoring. So it's basically a bunch of nested Python dictionaries so that it kind of auto-calculates each pair of model versus observation, and then aggregates among all the observations for that variable, all the variables for that indicator, and then all the indicators. So you kind of get like a nested scoring structure to help evaluate how your model did. So it kind of loads that kind of empty structure, and then now it's waiting for input. And then the next step is to load the model output itself. And again, it's kind of a shell at this point, so it's just kind of asking for all the variables that exist, and then it draws that from that files that have been uploaded into what I've called the active model directory. The next step is to determine which data sets actually match for the model output. So, you could, in theory, upload all the results from like BLM or LPJ guess or whatever, but you can also just upload a single variable, and in that case, it's just going to give you a single result for each of the observations that exist for that variable. Or you could upload several variables in independent files, but there's no real way to know a priori what variables are going to exist there. So, so the system essentially determines what variables exist in the model and then matches them up to the data sets that we have available on the Science Cloud. And then the next step is to actually load the data from the matching data sets. And in this step, we've actually got observational data on the ABoVE grid. So I'll take a quick aside to tell you that most of the data sets I've kind of in an offline manner reprojected to the ABoVE grid projection and then scaled it to various resolutions. So for like common model output resolutions, like half degree is kind of a workhorse resolution that I've seen most often. Honestly, the scaling isn't terribly involved. It's basically simple averaging or taking the most common depending on what variable type it is. But all of that is done offline so that so you've got those netcdf files that exist on the cloud, and then when you upload your model, that's also reprojected into the ABoVE grid, and then it takes a temporal overlap as well. So if your model runs for let's say 1980 to 2015, it's not going to do comparisons with observations that exist after 2015. And obviously we could probably change that if we wanted to get more of an idea of like longer term comparisons. But for right now, that's kind of how it is. So essentially, you know, separates out the um, the data set into a part that overlaps spatially and temporally with the model. So once you've got that, you actually do the statistics. So, you know, we're doing biases and root mean square and a couple other statistical tests there. And that's loaded into a statistics dictionary, and then basically transition that to that scoring structure from that scoring shell. And from that, there's a couple like automated plots, and then the big thing is kind of generating the web page from that. So originally, I basically just had a bunch of, the Python script that would populate an HTML with all the pertinent information. Now we're trying to essentially output it all as a JSON, and basically try to use that to populate kind of a fancier web page. So I mean, that's basically it. At that point, you're pretty much done. You've got your results, and hopefully you can use them. So this is just kind of an idea of a couple outputs. So this is, apologies, I don't remember which model this was, but it's looking at methane flux bias compared to wet charts, which is a data set developed by Anthony Bloom and colleagues. And what you're basically seeing is, in yellow is areas where the model is higher than the data set. And areas in blue are where the data set is higher than the model. You can see that that's done over the above domain here. And then obviously for the NEE data set, since it was only generated over Alaska, you only get the result over Alaska. And I think that's actually all I have for the presentation itself. I'd be happy to field questions now while I try to figure out how to share my screen and hopefully look at some of the, if you guys do want to look at the actual coding structure. If you don't, you can kind of, we can skip that part.
I think we should, well, let's open it up, if you can, if the terminal works for you.
Okay.
I think giving it a try is not a bad idea.
All right, I'm going to share my screen. My screen is being shared, desktop. All right, so everyone seeing the terminal?
Yep.
I can make it bigger. How do I? Yeah, all right. Oh, what happened? There we go.
Is there a way to make the text bigger in that?
Pardon?
I wonder if there's a way to make the text bigger.
I think there might be.
Well, I think if so all of you know, if up at the top of your screen you can turn your display to be a full screen mode, so that'll help a little bit too.
Apple Plus. Let's try that. Yeah, what now? All right.
There we go. All right.
And let me see if this works now. Yeah, cool. All right. Well, there's some font issue here, but I'm actually in. Hopefully this is allowed. I installed tmux, so I can kind of attach to that. So let me go out a couple steps. And so I've got just the above directory here, and that's actually a Git repository. Right now it's private, but if anyone's interested, I can make it public. It's on Bitbucket right now. And yeah, it's just something that, well, since I knew I was going to be losing access for a while, I decided to keep that somewhere. where I could reload it when it was time. And all that really has in it is a small README and the above package. So we'll go in here, and then we can see mostly a bunch of PI files, and then you can see those above study domain shape files, which is what Liz was talking about as available on the Oak Ridge deck. So let me do this one first. Yeah, that's not terribly important. All right, well, that's some interesting coloration here. So I basically got it sort of, if you recall that slide where I was talking about the steps where you load the structure and then you load the model and stuff, that's basically what this main program does. And so here's the step where I'm loading the structure. This is kind of what structure looks like. I'll go down to the bottom. So this is this gen structure thing that the scoring system, and then this program generates the structure based on a couple JSON files where I've defined the data sets we have and then defined like the benchmarks, so which variables are in the indicator and which observations match those variables. And then there's no page up on this thing. So there's basically, a bunch of classes here that have a bunch of scores, and so like indicators are what I've called children of the model score, and variables are children of the indicators, and so on, so that you can, so basically so that I can, go from bottom to top and calculate all the necessary scores. Terribly helpful, I don't think. So after that, we kind of execute the main portion of this, the main driver script. So, oh boy. Try that again. Well, that doesn't really work. Here, let's try something different. There we go. All right, well, now it doesn't have the cool syntax formatting, but at least you can see it all. So what we're doing here is loading the model, and that's a whole separate script that also has subscripts and subscripts. So it's basically looking in the active directory. AO here, I don't know if you can see that at all. Like model directory equals AO. I've defined my own open things that are specific for ABoVE. I don't know if that was a good idea or not. Yeah, so it basically just loads the model files and then loads all the output. And then we determine which variables we want to do. That's that which bars thing. And I don't know, it's kind of, there's a lot of moving parts to it. So when it works, it's awesome. And then the next step is to load data and then do the apps for it. There we go. Yeah, so, it's a lot of, for each, observation, do this, and then for each variable, you know, load all this stuff. Clearly it's not having a little trouble loading and stuff. Anyway, I don't know if anyone wants to see like specific code, I can pull that up. It's the kind of a workhorse engine is Xarray. If anyone's familiar with that package, it's sort of like pandas, but for multi-dimensional arrays, and kind of geared towards like NetCDFs. So it's pretty easy to open a NetCDF and Xarray, and it kind of auto-defines the dimensions, and then you can use when you've got your model output and then your data set loaded as Xarrays, you can do essentially temporal joins and spatial joins, all that fun stuff. So I guess I'll stop there for now. Field some questions, and then if anyone wants to see anything specific, let me know.
Thanks, Eric. We appreciate you sharing that with us today. And if anyone has questions, you can feel free to chat them in the chat box, or just unmute yourself and go ahead and ask them. So Eric, I think you said right now people wanted to upload data, they'd have to kind of send it to you, you'd upload it, and then people could try to use it, or that will be the intent.
Yeah, I mean, at this point, it's kind of, I don't want to say it's currently non-functional. It's in a bit of a limbo, though. So
in development.
I'm hoping,
it's still in development.
Yeah, under development. I like that. So certainly if you have data sets that you want me to put on there and kind of put into that format that I was talking about, the above grid and projection, and then the resolutions and stuff, that, I mean, frankly, that's most of the computing power with this, with the Above Science Cloud, is basically doing that. And there's some scripts in here like, load SMAP and load NCSCD and stuff like that. And those are basically things that I've done using the resources on the Science Cloud, because it's an involved process. And so if I wasn't to do that, and I was to do that when somebody uploaded the model, it would take a lot longer to actually run the benchmarking system. As of now, the evaluation, it's probably less than a minute per variable. It might even be faster than that. I'm not entirely sure, but it's pretty quick. So yeah. So and that obviously also runs on the system. Like I can. Do I even have any? I'll look at that. I'll look at that in there. That's not it. No. Okay. Anyway, sorry.
Eric, you may have showed this already, but can you show people again where all these data sets are located on the Science Cloud? And navigate to there so people can see.
Trying to remember.
I think it's pub repo, above products. No, MISC products. I think you're under MISC products.
Okay, yeah, let's try that. Let's try both. There we go.
There we are, model benchmarking.
Yeah. No.
So all these products are in the Science Cloud, and they are accessible, I think, for others to use if they wanted, and they're all in the above grid and protection. And I think Eric has put some metadata together for all of those, which are in our metadata system. So that's available for people if they want to use them too. Am I right on that?
Yeah. Uh,
Do we have any questions for Eric?
That's just kind of a sample. So,
Oh, nice.
Yeah. Put the projection in as a global attribute. And then, yeah. I do technically, I think I've subset the grid so that it only covers the areas that are within those shape files, the above domain, because, and I know people probably have, so like Eastern Canada and Western Greenland, I think, are technically within the grid itself.
Right, yeah.
There's a lot of extra stuff. I mean, in theory, I could always expand that, although I'd probably have to rerun all this stuff. But this makes it a little bit leaner as far as comparisons go. But it does encompass that kind of purple, the outer above domain of the two.
Now, we did make the grid is larger than the above domain, and that was just to accommodate people who had products that were for all of North America, for example.
Right.
For all of, all the way over to the east coast of North America. All right. Well, thank you, Eric. I'm not seeing any questions right now. If anybody has any questions for Eric offline, feel free to email him and ask him to. I'm just offering you up there, Eric.
Yeah, I assume everyone has my email address. It's just Dr.Stofferahn at Gmail. Not terribly clever. But yeah, it's up there.
Thank you. We appreciate you talking with us today. And if you would just stop sharing, and then we'll do some system updates. Here, let me see. I can request control.
How do I do that?
I think up at the top, the top of that Adobe Connect add-in, there should be something that says stop sharing. Further up.
Like up here?
Up further.
Can you see my card?
I can see her, but I think because keep going up.
Aha, that thing? There it is.
You find it? Okay, great. All right.
Cool.
I had just 2 system updates for today that Scott Sino mentioned. He's on the call as well, and Scott is one of the system administrators with the NASA Center for Climate Simulation, who does the sysadmin work for the Above Science Cloud. And he wanted to mention that this show quota option is available, so you can type show quota once you're logged in, and you can see your utilization. And Scott, did you want to talk about it a little bit more?
Sure. The current show quota command is we had a lot of users seeing the Discover documentation, which it instructs users to use show quota. So we invented an analogous utility on our side. It only updates every 24 hours, so if that so when you're looking at your quota information, it might be a little dated. We may bump up the rotation on that so it gives more up-to-date quota information if that becomes an issue. We do have large memory nodes that'll be coming into play probably in 2 or 3 month time frame. We do have some available on a limited basis. Paul Montesanto is currently utilizing 6 for some of his runs, and he's been doing so for the duration of this week, and so far so good on that. If you do have near-term needs for higher memory nodes than what we normally allocate, do feel free to let us know, and we'll try to fill that as best possible. I know there's been some interest in the LVFS mechanism. LVFS is a file system interface that makes a remote collection look as if it's local to the system. We were using it in the past as a means to get to predominantly MODIS data over in Building 32. Unfortunately, they had to take down their former distribution mechanism, which was based on FTP, that it was using. So we are reworking the LVFS interface using an alternative protocol. We've got a beta version out there that's clearly falling far short of where we need it to be, but we are in process of getting the author of the software an account in the Science Cloud so he can debug it firsthand. And the only other thing on my list was the version of GDAL we provide by default, if you don't source any environments on your shell, has been 2.0.2 for a long time. We're going to update the default version to a 2.2.2 GDAL rev, which has been tested by many users at this point. We have no reason to believe it'll have any negative impact. And that's all I got for this Friday.
Great, thanks, Scott. Anybody else with a system update on the line? Anybody else from NCCS with anything that needs to get added? Okay, any questions for NCCF staff who are on the line? This is also a time for Science Cloud users to bring any questions forward, any issues that they're having. I know we have 2 interns this summer who are doing some processing and hope to be using the cloud, and so I know they've been emailing back and forth with support, and so you can always also email support@nccs.nasa.gov. They're very responsive and get back to you pretty quickly. Great.
Hey Liz, I think I probably asked about this like a couple months ago, and maybe I just forgot. Is there any plan or anything to implement Docker?
Let maybe Scott talk about that. I do remember you bringing it up, but I don't think right now we have that capability.
Okay. Okay.
Yeah, that's a subject that's under discussion at the NCCS to integrate. We do appreciate that a number of other data centers have chosen to accommodate that, and we're working towards it.
Okay, cool. Thanks.
All right. Well, thank you everybody for joining us on the call today. This is probably the last one for a few months. We usually take off in July and August as people are out doing field work. So if you do have anything that comes up in the summer, you can always email support@nccs.nasa.gov for help, or you can email me, and we will help you as best we can. They're always happy on this. Oh, and you know what? One other thing I will make sure to say, actually 2 things. One is, if you're writing a paper and you've used the Science Cloud to do your research, make sure you cite the Science Cloud. There's some guidance up on our website on how to do it, saying something like, this research utilized the NASA Center for Climate Simulation to process data or something like that. And so make sure you do that. If you are creating an ABoVE product, make sure you have it listed on your ABoVE project profile so that it can be counted, and in there's a checkbox to say if you're using the Science Cloud or not. So that helps us to keep a record of who's using the Science Cloud and how it's getting used, so we can continue to justify what a great service we're providing for everyone. And I think those are the the things I wanted to mention. So, and then also, if you ever have a topic you want discussed on one of these webinars, please let me know, and we can work it into one of our future webinars. So we're always happy to accommodate that. So thank you for your time today, and I hope everyone enjoys their summer and get some great field work in if you're planning on that. And we will talk to everybody in the fall. Thanks a lot.
Thanks, Liz.